Hello students, today we are going to learn about the arithmetic instructions in 8085. Now the name itself, arithmetic instructions, these groups of instructions will perform the arithmetic operations, and these arithmetic operations are like addition, subtraction, increment, decrement, etc. Okay, multiplication, division is not available in 8085. Direct instruction is not available in 8085. Multiplication is done with the help of the repetitive addition, and division is done with the help of the repetitive subtraction. So main instructions are for addition and subtraction, as well as for incrementing and decrementing the content. Now most of the instructions in this group will affect the flags because it is an arithmetic operation. One of the operand must be in the accumulator when you have the binary operands, that is binary operation. That is, for example, when you are adding, you need to add two numbers. So one number will be in the accumulator, that is A register. And the result will always be stored in the accumulator after addition and subtraction, etc. So now we will see the first instruction, which is nothing but called as the addition instruction. Let's see. Now the addition instruction, the syntax of the addition instruction is ADD, that is add, and then you have to mention the register name or M. We have already seen what are the registers in 8085. A, B, C, D, E, H and L are the general purpose registers. So any one name of the register you can write. Or M stands for the contents of the address specified by HL register pair. So HL register has whatever 16-bit number that is used as an address, and the contents of that address is nothing but M. So either you can use ADDR or you can use ADDM. So in this case, the contents of the register or memory are added with the contents of the accumulator, and the result will be stored in the accumulator. For example, if I say ADDB, and suppose B register has 06, H represents the hexadecimal number, and the accumulator has 0A, then the addition of 0A and 06, that is 10, will be in the that is the result will be in the accumulator now. Okay, this is the addition, and the B register contents remain same. Now because of this answer, we had already seen the flag register has 5 flags. So because of this answer, these 5 flags will be affected in the following way. The MSB of the answer is 0, so sign flag is 0. The answer is non-zero, so 0 flag is 0. There is a carry. When you add these numbers, there is a carry from this place to this place. So auxiliary carry bit of the flag register is nothing but 1. The number of ones in the answer is 1, that is odd number of ones, that is odd parity. Therefore parity flag is 0. And there is no carry from this place to this place. So your carry flag is 0. So the flag register will have the answer as 010 in it. So because of this answer, the flag register which is affected, it will have the flags will be affected, and the flag register will have the answer as F10 in it. Similarly, you can have add M instead of R. If I say M, so that means HL register has, for example, 6000, and the 6000 address has 35 in it. We are assuming this data, okay? And suppose A register has 0A in A. Then after the execution of the instruction, the A register becomes this plus this, okay? That is A plus 5, B, C, D, E, F, correct? And then 3 plus 0, that is 3. So 3F will be in accumulator, and the 6000 contains remain 35. This instruction will also affect all the flags, and these are 1 byte instructions. There is a term which is called as the addressing mode of the instruction. The addressing mode for ADDR will be nothing but the register addressing mode, and indirect mode of addressing for the LED M. Now you have to think about what will be the flag register contains in this case. So please try this at home. Okay. The addressing mode, number of bytes, flags affected, all this is the extra information which you have to answer when the explanation of any instruction is asked. Now similar to add, we have ADI instructions. See, move MVI. Similarly, add ADI. So when the number, exact number which is to be added, that we know, then we use the ADI instruction. So ADI, and then you have to mention the 8-bit number. So that 8-bit number which is specified in the instruction will be added with the accumulator, and the accumulator contains and the result will be stored in the accumulator. So this also will affect all the flags, and this has the immediate addressing mode of the instruction. Addressing mode of the instruction is nothing but immediate addressing mode, and it is a 2-byte instruction. For example, if I say ADI 78, suppose accumulator has F2, correct? And I am adding now 78 to the F2. So this is your 78 and F2 in the accumulator. Now if you see, if these are added, 0 plus 0, 0, 0 plus 1, 1, 1 0 plus 0, 0, 1 plus 0, 1, 1 plus 1, 1 0, 1 for carry, 1 plus 1, 1, plus 1, 1, again 1 for carry, 1 plus 1 plus 1, 1, 1 for carry, 0 plus 1, 1 plus 1, 0, and the carry. Now here the carry is generated. This is the 9th bit of the answer. So the carry flag will be affected with this. That is, carry flag will be set now in this case. And this 8-bit answer, the remaining last bit of the answer, will be stored in the A register. That's why you have 6A in accumulator after addition of 78 and F2. Okay. Now with this answer, what will be the flag register that you will have to find out? So what will be the flag register? In this case, sign flag will be 0, 0 flag will be 0, auxiliary carry is not there, so it will be 0. The number of ones are even in the 8-bit answer. Therefore, parity flag will be 1 and carry flag will be 1. That is how your flag register will be affected by this particular instruction. Now we will see what is ADC instruction. Now similar to add, we have the ADC instruction. The syntax is similar, that is ADC, and then we have to mention the register and memory. Usually this instruction is used when you have more than 8 bits to be added, right? If you have a 16-bit number, then initially two 16-bit numbers, then initially the last 8 bits are added first, and then the next two 8 bits are added. And in this case, if the last 8 bits are added, then if any carry is generated, that will be added with the higher 8 bits when I am adding of the two numbers. So that means I will have to take into account a carry when I am adding the number which is more than 1 byte. Okay, 2, 3 numbers which are more than 1 byte. If I have to add, then I will have to use the instruction which is called as ADC R or ADC M. So here the contents of the register or memory will be added with the contents of the accumulator with the previous carry, if any. So the result is again stored in the accumulator, and the general format, if you see, accumulator contents will be affected. How? By the answer. How? Accumulator plus register or memory contents plus whatever was the carry. The flags will be affected after execution of the instruction. And now if you see ADC B, correct? If B is 6, A is 0, 8, and before execution of this instruction, if the carry was 1, then after execution, accumulator contents will be 1, 1. Why? Because 6 plus A plus previous carry, these all will be added, and this answer 1, 1 will be stored in the accumulator. B register contents will remain as it is. And with the answer, as we had seen previously, we have to find out what will be the flags affected. Sign flag will be 0, 0 flag will be 0, auxiliary carry was generated, therefore auxiliary carry will be 1. Even parity, so parity flag will be 1, and there is no extra bit in the answer, so carry flag will be 0. So these are the 1 4 will be the contents of the flag register, and now the new carry which is generated will be nothing but 0. There is no carry generated, so carry flag will be 0. If you have ADCM, again you have to do the same thing. If HL register contains has certain 16-bit number, for example 6000, this we are assuming, okay, and 6000 has 35, and accumulator contains are 08, then before carry, before execution, if the carry is 1, then after execution of the instruction, A becomes 35 plus 0A plus 1, okay, and that means it will become 40, 40 in hexadecimal. All the addition will be in hexadecimal. These instructions will affect all the flags. Again, these are 1 byte instructions. And if it is ADCR, then it is a register addressing mode. And if it is ADCM, then it is indirect addressing mode. Again, you will have to find out what the flag register contains in this case. Okay. Now, if it is ACI 8-bit, it is similar to your ADI. So, 8-bit numbers will be added with whatever was the previous carry. Okay, and it will affect the all the flags, and the result will be again in the accumulator. So, if I say ACI and then 78, if accumulator was F2 and the carry was 1 before execution, then after execution, accumulator contents become 6B. Why? 78 plus F2 plus previous carry, all the things will be added, and whatever is the answer, correct, that particular answer is nothing but this. It has generated a carry. So from this particular answer we will see what will be the flag register. So this is how your ACI instruction works. So we had seen all the 4 addition instructions. One was ADDR or M. Similar to that is ADCR or M. So ADDR is add register contains or memory contains with the accumulator. ADCR or M is add register contains or memory contains with carry. Correct? And the result in both the cases will be in the accumulator. All flags will be affected. We have seen ADI and then 8-bit number, and ACI and then 8-bit number. Whatever is that 8-bit number will be added with the accumulator, and answer will be stored in the accumulator. If it is ACI and whatever is the 8-bit number, the 8-bit number with the carry bit will be added. Carry 1 also, 0 also, it will be added, and the answer will be stored in the again accumulator. These will be 2 byte instructions. Okay. Now similar to these are subtract instructions. Those we will see in the next session. Thank you.